Okay, in this video we're going to be looking at fractals and card magic, okay? And this will be the first of its kind, I believe, found anywhere. Because to my knowledge, no one has connected fractals to card magic. Okay, so what I thought we would do is begin with an effect that you could do right away, and then we'll look at the fractal nature of what it is we're doing. Okay, and the larger fractal from which this particular pattern comes. Okay, so here I have, as you can count, 16 red and black cards of various face cards and number cards and different suits, of course. Okay, so what I'm going to, and you can tell that they're well mixed if you look at them here, but nonetheless, I'm going to give you an opportunity to switch cards if you would like. Okay, so maybe you think they're in some special arrangement. So let's say you choose to take this one right here, and let's say you switch it with the black queen. Okay, that's fine. Are there any others that you would like to switch? The red jack over here, okay, what do you want to switch that with? The red 9, okay, that's fine, perfect. Any others? The red ace here, you would like to switch it with the black ace over here, okay, that's just fine. Okay, so you happy? Okay, now we've really kind of, if there was any structure to it, it's a total mess now, thanks to your selections. Okay, but nonetheless, what I'm going to do is I'm going to mix the cards, and now I'm speaking to you as the performer. The particular packet that we're working with, if you go to my channel, it's called a quasi-bessey sequence of order 16, and it can be mixed in hundreds of unique ways and not harm it. Okay, so I'll have links in the description below. So this left-right shuffle is just one of many shuffles you can do, and it won't harm anything. Okay, and then maybe the spectator asks for left on right. Okay, very good. Maybe they ask for one more. Okay, that's great. Okay, and maybe this time they want right on left. That's fine. Okay. And from here, what we're going to do is deal out into two piles yet again. But this time, we're going to keep them separate. Okay, so I have a pile here and a pile here. So what I'm going to do here is I'm going to give you a choice if you would like to mix this packet using a very powerful shuffle that genuinely makes a mess of virtually every packet of cards out there. And it's called the Australian Down Under. And everything I just told you is absolutely the case. This is true. So would you like me to perform a down under on this one? You would. Okay. So this is how it goes. You go down, and the next one goes under, down, under, down, under, down, under, down, under, down, under, down. Last one goes on top. Okay. Now we can perform that shuffle more times on this packet if you like, or we could perform it on this one over here as many times as you like. Would you like to do any further down unders of these two packets? I know we haven't done this one, but that's your choice to leave it. Just leave them as they are now. Okay, that's fine. Okay, now what we're going to do is we're going to deal out each of these into two piles. Okay. Now, if you've seen fractals before, you know that they have, quote, a self-similarity, okay? And so if you kind of pay attention to this left-right shuffling, it's very much reminiscent of essentially zooming in on the fractal, okay, or breaking it up into smaller parts, okay? So now we have these 4 packets of 4 cards each, okay? Now each of these can be mixed using the down-under shuffle if you would like. Not that one. Okay, what about this one? Yes? Okay. So down, under, down, under, down. Last one goes on top. What about this one? No? How about this one? Do it twice? Okay. That's fine. Down, under, down, under, down. Last one goes on top. You ask for a second time. Down, under, down, under, down. Last one goes on top. Okay, so now what we're going to do is we're going to repeat this left-right dealing one more time. Okay, just like that. We're going to probably go off the screen. Left, right, left, right. I don't need to go off the bottom. We have plenty of room that way. It's the left or right that I'm worried about. This one here, left, right, left, right. Okay, same actions as we've been performing on the others. And then left, right. Okay, and then we're going to have to go off a little bit. I apologize for that. Let's see here. Okay, so what I want to do at this point, so we will go a little bit off. I have no idea why I'm down here so low, so I apologize for that. Okay, so I need you to know that these cards are not marked in any way. In fact, when you go to the tutorial, you'll realize that everything I'm doing is genuine here, and you'll be able to do it as well. So what I'm going to try to do is I'm going to try to get a sense as to whether any of these packets here, there are 2 cards each, there's really a couple of possibilities, generally. These cards could either match in color or be different. And there's, more than one way for them to be different, or to be the same, actually. Okay, so these could be the same color, same, different, same, different, or who knows, okay? So I'm going to try to get a feel for what your decisions have actually done to this packet of cards. Do any of these match in color? And if so, how many? Or are they all of opposite color? Okay, which in and of itself would be pretty surprising. Okay, so... Oh, okay. Let me double check that. Well, let me tell you what I think has happened because of your choices. I believe that there's 2 red pairs and a balancing number of black pairs. So there's 2 red pairs and 2 black pairs and 4 pairs of different colors. That's what I'm getting a sense of. Okay, so 2 red and 2 black. Let's see how we did here. Okay. Oh, 2 black. There you go. So there's one matching black. Nothing there. Those are different. So we're looking for 2 red pairs and 2 black pairs is what I was sensing. Okay. Let's see how we did. So we only have 1 black pair. Oh, we have a red pair. Okay. So we need another red and black pair if my intuition... Oh, boy. Okay. Pressure's on, guys. I predicted that there would be 2 black pairs and 2 red pairs. And guess what? We're down to the last 2 pairs. Okay, so I'm hoping that one of these is a red pair and the other is a black pair, and that we don't have these different colors. And I'm afraid to look. Okay, we got 1 red pair, so we're covered. 2 red pairs. Check that off. Okay, now the real pressure... I'm predicting that these are going to be black, and they are indeed. Okay. Wow, how did we do that working together? Okay. Well, let's take a look at this. Like I said, it's using a fractal structure to accomplish this. And I want to just point out at the beginning, if I had not allowed you to switch cards, what would have happened is all of these would have been of opposite color. Okay, so all pairs would have a red and a black. Well, one way that you could frame that is you could say, well, speaking to the spectator, have you heard the phrase that opposites attract? Okay, so you could have your whole narrative built around that aphorism that opposites attract. And then in the very end, all of these pairs will consist of cards of the opposite color, which is just mind-blowing, actually, if you think about all of the free choices given to the spectator along the way. Okay, so how does this work? So what I thought I would do, and let me just bring up a different screen for a moment. Okay, so on the left-hand side of the screen, I have a write-up. It's called Most Important Fractal in Math Card Magic, the Thue-Morse sequence. Okay, now if you've heard of this sequence before, it's also called the fair share sequence. Okay, Now, I do want to give you the true order in which all of this came about. Okay, so in my study of mathematical card magic, I discovered sequences that I've called either Bessey sequences or quasi-Bessey sequences. And I've worked with those for several years in my research. And then I had a colleague point out to me, he said, you know, these Bessey sequences that you've discovered, I just noticed that they're finite sections or segments of the Thue-Morse sequence. And I looked at him like, okay, what's the Thue-Morse sequence? Because my specialty is topology, not combinatorics, or an area that would study Thue-Morse sequences. Okay, so I had never heard of them before, but once I looked up on Wikipedia what the Thue-Morse sequence is, I realized that indeed these special sequences that I've discovered that give you packet structures that are virtually impossible to mix using the systematic mixing procedures that are commonly used today, I could see how the Bessey sequences really are truncated portions of this Thue-Morse sequence, which is a fractal. Okay, and it gives rise to some really interesting geometric representations as well that I can link below in the description, or if you just look it up, you'll find that the Thue-Morse sequence can in fact generate traditional fractals. These are geometric constructions. Okay, here's the classic Thue-Morse sequence. Okay, so I had to cut it off because it is an infinite sequence. Okay. Now, as I mentioned here, I prefer, in fact, well, because of how I discovered these Bessey sequences and quasi-Bessey sequences, I have mine starting with 1. So like 1, 0, 0, 1 instead of 0, 1, 1, and so forth. So essentially, if you switch zeros for ones and ones for zeros, the classic representation of the Thue-Morse sequence will agree with what I've done with these Bessey sequences and quasi-Bessey sequences. And then what I've done is I've bracketed off that the first 8 values of the Thue-Morse sequence is a Bessey sequence of order 8. I have a lot of videos and very surprising card effects using this sequence structure. And then if you group together the first 16 zeros and ones, you get what I use today. It's a quasi-Bessey sequence of order 16. And then if you group together the first 32 values here in the Thue-Morse sequence, it gives rise to another Bessey sequence of order 32. Okay, and I have that on my channel as well. Okay, so what I thought we would do is do something I don't think I've done before, actually, in helping people understand how these actually work. So kind of see it in action here. Okay, so I think I'll switch over to my larger screen real estate here, so I can use the entire pad here. Okay, so what I'm going to do is I'm going to, with you very quickly, we're going to build a quasi-Bessey sequence of order 16. Now on my channel I do have a slick way of doing it that Warner Miller came up with, and I can also link that in the description below. But here I thought we would just do it together. So if you want to think of the red cards as ones and the blue cards as zeros, okay? So what you do is you go like 1, 0, 0, 1. Okay, that's kind of the first little part. And then you repeat this, but switch the colors. Okay, and so now instead of a red here, I'll have a blue, a couple of red instead of a couple of blues, right? And then instead of a red here, I'll have a blue. Okay, and then what you do is you just build this, switching red for blue and blue for red. Okay, so for example, see we have red here, so I'll go blue, red, red, blue. Okay, we're kind of building the second half essentially. And then instead of the blue here, I'll go red, a couple of red there, so I'll go a couple of blues. Sorry. Then a blue here will change to a red there. Okay? So this is the kind of structure that I started with. So why don't we go ahead, we'll put it all together and you can kind of see what's going on here. And then what I'm going to do is something really cool, because you're going to see the fractal nature of this thing and how it's not being harmed by the different shuffles that we'll show you here. Okay, so well, this is technically the top here. So this is like 1 0 0 1 0 1 1 0 0 1 1 0 1 0 0 1. Okay, so it's a quasi-Bessey sequence of order 16. Okay, so the first thing I want you to notice is if we deal this packet out and then randomly stack, okay, maybe we'll stack right on left, what will happen is you'll get back the exact kind of organization of the colors of the cards, okay, that we had before, and we do. Okay, now if we had stacked in the opposite order, all that would do is switch the colors. Reds for blues and blues for reds. Okay, but technically both of those are, quote, quasi-Bessey sequences of order 16, and they're both equally useful. Okay, so if all of them switch, it's not a problem. Okay, now watch what happens if I do a left, right, left, right. Now this time we won't stack. Okay, and then I actually gave you the option to down under shuffle any of these. Okay, now maybe I'll have you do that on your own just to keep this video from getting too long, but what you'll find is the down under shuffle will not fundamentally harm these packets. Now, depending on the size of the packet, it may change it to what's called its inversion, which is just that packet with the colors switched, kind of like we were talking about. So the down under shuffle won't fundamentally harm either one of these. But look at what happens if I deal out into two piles. See, this is what we were doing. And then you just continue on. Go up, let's make use of our space here. Like that. Kind of go off again. But look what's happening already. Look at the pairs. So far, each one has a red and a blue. Same thing there. Maybe we'll go up here. Okay, so you're guaranteed to have each pair consisting of one of each color. Okay, so the idea is whatever kind of pairing you want at the end. So like the red cards could be even value cards, and the blue could be odd value cards. The red cards could be face cards, and the blue could be number cards. The red could be hearts. The blue could be spades. Okay, so there's endless possibilities for how you can take advantage of the fact that this packet is really unharmed by all of this mixing that we're doing. Okay, and so to kind of bring things full circle, this is not the ending we got, right? Do you remember? We didn't have all of them of kind of opposite color, right? We had two red pairs and two black pairs. Well, can you kind of guess how that happened? Okay, so let's go through, and what I thought I would do right now, I just thought of it. Let me show you the Warner-Miller slick way of creating a quasi-Bessey sequence out of two kind of dichotomous blocks here. So you have top 8 cards are of one kind, maybe face cards. Bottom 8 are another kind, maybe number cards. Okay, so this is what Warner-Miller discovered, and I'll put a link in the description below. If you take the top 2, he calls it the triangle deal. So I'm just putting out pairs of cards. And we'll deal it out into a triangle like this. You just go clockwise. Okay. Same thing here, and then here, and then the first pile that was dealt to, you pick that up first and then stack in the opposite order. Okay, so you just go counterclockwise, and then if you finish that up with a mange over under or under over, it doesn't matter, both work fine, you will arrive at a quasi-Bessey sequence of order 16, which is essentially the packet that I started with. Okay, I'll just show you that. Okay, so it's like 1 0 0 1 0 1 1 0 0 1 1 0 1 0 0 1. Okay, so this is the kind of arrangement. If you go back at the beginning, this is the kind of arrangement I had with the different colored suits. Okay, now if you remember, what did I do? I allowed you to switch. Okay, so here's the rule, and you can use it as well. If two cards of opposite color are switched by the spectator, now what that will mean is, so like for example, if they switch, and maybe we'll just switch it with the neighbor there. Okay, it's kind of simple. The switching of a pair like that will lead to one red pair at the end and one blue or black pair, here blue, I guess, one blue pair at the end. So for each swapping of different colors, you pick up one more pair of each of the colors that you have, okay? Now, of course, if you swap a red for a red, it doesn't do anything, and I actually did that, so that won't change anything. But I think I went ahead and I switched another red for like a different blue or something, like over here, okay? Okay, and so what that's going to do is at the very end, we're going to have now two red pairs and two black pairs. And then you can kind of pretend to divine that, okay? So you just deal out left, right, left, right. Spectators free to actually stack those however they want. You can perform any number of left-right shuffles as you like. We'll just do one here. Any one of these can be down-under shuffle one or a million times or not at all, okay? And then once you've done what the spectator asks you to do, with either further left-right shuffling or down-under shuffling, you deal out again like that, okay? Move those up. These can be down-under shuffled as many times or no times at all, okay, if the spectator doesn't want. And then from there, you just deal out into two piles. Maybe this time for the first time, I'll make better use of this blasted pad here. And I should have planned ahead a little better. Okay, so what did I promise the outcome would be? I promised that there would be two red pairs and two blue pairs, or black pairs if you like, if we're looking at suits. And so we have two red pairs and then two blue pairs. The others are opposite color. Okay, so anyway, that's how I did the original effect. But I just wanted to point out that this structure comes from special sections of the Thue-Morse sequence, which is indeed a fractal construction, okay? And it's the fractal nature of that sequence that allows Bessey sequences of order 8 or 32 and so forth, or quasi-Bessey sequences of order 16 and 64 and so forth, to be mixed in so many different ways and not harm them. The worst thing that will happen to them is it will switch essentially zeros for ones or ones for zeros. It will like reverse the packet in some sense. But if that happens, it will not undermine anything you hope to accomplish. That's the bottom line, like right here, okay? Anyway, so I thought I'd share this with you. So there's a lot of powerful ideas here that you can now use in countless ways. And take a look at some of the videos and series that I'll link in the description below that go into, okay, how did I come up with Bessey sequences in the first place? And how do we know that they are preserved by all these different mixing procedures? And the most surprising one that preserves them or leaves them unharmed is the down-under shuffle, since it will destroy just about every other packet structure out there. It truly will. In fact, my conjecture is it's the Bessey sequences and quasi-Bessey sequences that are uniquely the only structures that are not damaged or harmed by the down-under shuffle, okay? So I haven't proved that in general. That's my guess. That's why I call it a conjecture there. And if that's true, boy, does that make these Bessey sequences and quasi-Bessey sequence very special, because it means that they're extremely rare. They're like the only ones out there that have the degree of invariance or ability to not be harmed by so many of the systematic mixing procedures used today. So anyway, thank you for watching, and take a look at other videos on the Absolute Math Magic channel.